So let us now look at quadratic equations. So what is a quadratic equation? It's an equation of this form. So you have ax squared plus bx plus c equals to 0. So you have here a quadratic function equals to 0. Then you have a quadratic equation. So when does equations like this arise in real life? Yeah, we have already seen an example of that. We saw this earlier. For example, this guy threw a ball or a rock or whatever up. Then this was the height of the ball above ground. Then we wanted to find out when it hits the ground. Then we got this equation. And this is a quadratic equation. Because we can rearrange the order. We write the t squared first. Then we will have this. And of course it doesn't matter if you have t or x or whatever kind of letter we have. It's still an equation. The unknown, what the name of the unknown is, doesn't matter. So here we have a second degree equation or quadratic equation. Since this is written of the form a t squared plus bt c equals 0. So this is a special case of this. So a quadratic equation can arise, for example, in those situations. So now we want to find out how can we solve an equation like this. So let us do that stepwise. Let's start with some simple quadratic equation. And the most simple one is this. And how should you solve that one? Yeah, it's very easy to see that the only solution is 0. But you can realize that, for example, if you write x squared as x times x, you see this means x times x. So what this means is that if you have a number and multiply it by itself, if this should be 0, then the number here must be 0. If you take a product of a number with itself, for any other number than 0, it will not be 0. So the only possibility here is that x is equal to 0. Okay, so the only solution to that one is this. So we are using the fact that if you multiply two numbers and want the product to be equal to 0, then one of the numbers must be equal to 0. The only situation when it happens that the product is equal to 0 is that if at least one of the numbers are 0. So at least one of these must be 0. But now it's the same number here, so it means that the number must be 0. Okay, so this situation has the solution, or the equivalent equation, x equal to 0. So this is the only solution. Okay, so that's one extremely simple one. So let's take a little bit more involved. Let's take this equal to 4, for example. Okay, how should we solve this one? Okay, again, it's easy to say that, okay, I just guess that a c is 2 or minus 2. But you should do it carefully. Remember now that we want to solve this by stepwise making equivalent equations. So how can we make an equivalent equation? First of all, we can subtract 4 on both sides. Then we will get this. That is, we get this. Just simplify. And now this equation, can we make an equivalent equation of that one? Yeah, this one here we could write as a product. Just rewrite this thing as a product. And how can we do that? Then we can remember the rule for, what rule do we have then? Then we have the rule for taking the difference of two squares. What was that? The rule for taking difference of two squares. You can use this rule that we saw previously in the earlier lecture. So we can use that here. What do we have here? We have x squared minus 4. So in this case, x is the same as a. So we should have x here and x there. And what is b? Yeah, b is equal to 2. So we can write this as 2. Since we can write 4 as 2 squared, you see that we can identify b as 2. So we can rewrite this as this. This expression we can rewrite as this. So the left hand side here we can now write as x minus 2, x plus 2, and it's equal to 0. So what was the point of that? The point of that, now we are back at this situation where we have a product of two numbers. Here's one number, and here is the other number. And here we have product of two numbers that should equal to 0. The only possibility for that to happen is that if one of these are 0. At least one of these are 0. So here either x minus 2 must be 0 or x plus 2 must be 0. Yeah, both could be 0 of course also, but at least one of them must be 0. Okay, so now we have transformed these equations to two linear equations. Okay, so can we make an equivalent equation of that one? That's easy. Just add 2 on both sides. And that one we can subtract 2 on both sides. So we see that the only possible solutions to this, only possible solutions to that is if x is equal to 2 or x equal to minus 2. And that we have solved by making equivalent equations. Okay, so that's how you can solve an equation of this type. Okay, what would happen if we had like this instead? Yeah, then we can see directly there are no solutions, because there are no number that we can multiply by itself that will give a number that is negative. So for no real number, there is no real number that we can multiply by itself that will make it negative. So there are no solutions to this. Among the real numbers. Okay, so that we can see directly. Let's say we have this equation instead. So now it's starting to get a little bit more complicated. So what should we do then? Yeah, the thing here is we can factorize this. Trying to get back to our old situations of having a product of two numbers instead of having one sum here. So I can rewrite this as this equation. These two are equivalent. And now I have product of two numbers. Here's my first number, here's my second number. And if this should be 0, then one of them must be 0. So either x must be 0 or this x plus 1 must be 0. So x is 0 or x is equal to minus 1. So we see that the only solutions are these two. So there are two solutions, and there are 0 and minus 1. So in this case it's fairly easy to solve, and the reason for that is that there is no constant term here. If there would have been a constant term here, for example, standing a 5 there, we couldn't have factorized it in this just such a simple way. What should you do, for example, if you have 3x squared equal to 12? Yeah, here's not so difficult. You can just divide on both sides with 3. And this will become x squared equal to 4. And then we're back at the old situation. We have already seen that the solutions to this are plus and minus 2. Or if you like, plus minus square root of 4. But that's just the same thing. Okay, but then we are prepared for solving any quadratic equation. So we now want to solve a general quadratic equation. It means any equation having this form. Let's take a particular example. Let's, for example, take x squared plus 2x minus 3. So what is the technique now? The technique now is that we have already seen before, when we had quadratic functions, how we can write this in the form of ax plus b squared plus c. So on the left hand side here we have already seen how we can rewrite it like that. So that if we can write the left hand side like this, we will see that it's easy to solve it. So let us first do that. Okay, then we have to remember that we should write this as a square of the sum. And if you want to rewrite this as this, then we see that this number must be the half of that one, because that times 2 should correspond to that one. Now if you have to go back to the previous lecture to see a quadratic function lecture to see how we did this, if you don't remember that, because now I will assume that you have done that before. So here it must be 1, because x squared becomes that one. X times 1 times 2, double product becomes that one. And then we will have 1 squared, 1. But we don't have 1 here, so let's remove that one. And then this one we also need to take into account, so we write minus 3. So this now is exactly the same as written here, just written in a different way. So now we have written the left hand side in a way looking like this. Or at least after we have now simplified this to minus 4. So if you have an equation like this is easy to solve. And that we will show now how you do that. First of all, we could add 4 on both sides. Then we get this. What now? Yeah, here we have a number multiplied by itself. That should equal to 4. Okay, this number should multiply by itself equal to 4. Okay. Then what to do then? Then we see that this number must be either 2 or minus 2. So the number x plus 1 here must be either plus or minus square root of 4. For if we have a number here, we want to square it and become 4, then the number must be plus or minus square root of 4. That is, it must be plus or minus 2. Okay, so see here we have a number inside the parentheses. Square that's equal to 4. That means that the number must be plus or minus 2. So now we have 2 equations. This is just a shorthand for writing 2 equations. What this means is really we have 2 equations. The first one equal that, and the second equation equal that. So now we have to solve both. But they are simple linear equations. So this is x equal to 1. This x equal to minus 3. So we see here now that this equation has the solutions 1 and minus 3. And that's the only solutions there are. Let us take one more example before we continue. So let us say we have 3x squared minus 9x minus 12 equal to 0. Okay, so how can we do this? Yeah, we could first of all simplify this, because the 3 here is in common all 3 terms here. So you can divide both sides by 3. And we know that if we divide both sides by 3, we make an equivalent equation. So here it becomes 3x squared divided by 3 minus 9x divided by 3 minus 12 divided by 3. And here it's 0. So this becomes x squared minus 3x minus 4. Okay, Now we can do our technique of rewriting this in the form of x plus b a squared plus c. So we use our old technique for doing that. In this case, it will become like this. So it's easy to start. There's nothing in front of x squared, so it must be x here. And we have a minus there, so we must have a minus there. And this one, we must have half of that one here. Since that times 2 should equal that. If you remember the rule for squaring a difference. Okay, so this squared becomes this. Product of these two times 2 is that one. But this squared, what is that? 3 squared. 3 half squared, that's 9/4. And 9/4 we don't have in this equation, so let's remove that one. Okay, so now we take away that one, so that now this one disappears when we square it. But this we still need to keep. So now these two sides are two identical mathematical expressions. Just rewritten. Okay, so let's simplify it. 9/4 minus 16/4, that's 25/4. And let's move the constant over to the other side. And we'll have like that. Okay, what now? Here we have a number. When we square that number, we should get this. That means that this number must be the square root of 25/4. Because when we square this one, it should be 25/4. But it could be both plus and minus. Okay, so what is square root of 25/4? Here we could use the rule that we could square root up and down. Like this. Square root of 25, that's 5. Square root is 4, that is 2. Okay, so we have two equations here now. Let's solve first the first one with the plus sign. Then we see that x is equal to, we move over to the other side, 8/2, or 4. And solving the other one with the minus sign is this. And if you now move that over to the other side, this will minus 2/2, that's minus 1. So we see here the solutions here are now 4 and minus 1. So that are the two solutions to the original equation, which was this one. So this is the general technique for solving an equation. So this technique will always work. Sometimes it can happen that when you come this far, you can end up with a negative number here. For example, let's say it would have been like that. Then you see there are no solutions. If you come to this step and there is a negative on this side and a square of this on this side, then you know that there are no solutions, because no matter what you square, you can never get negative. So sometimes you have to say that, okay, there are no solutions. There is also a general formula for solving second-degree equations or quadratic equations. If you have a quadratic equation like this, you could solve it in the way we have just done. But there is also a finished formula, an explicit formula for the solution. And the formula for that one is this, that may be or maybe not familiar from before. So this is the solution to the equation, or the solutions. because for a second degree equation there are either 0, 1 or 2 solutions. And this is the formula to get them all. Let's first show an example how to use it, then we can see where this formula comes from. So let's say that we have this equation. Let's take the one we just had. The one we just had was this. And we saw that this had solutions of x equal to -1 and x equal to 4. So let's see if we can reproduce these solutions with this formula instead. And of course we should if everything works out correctly. So what do we do here? We see that a is equal to 3. b is equal to -9. So it's important now to remember that you have to have the sign also. Because it has a plus b and it's minus. So this is plus minus 9. And also here for c is -12. If we now plug that into this formula here, minus b, that's minus 9. And now we need to take the square root here. b squared as -9 squared. So here's b. Just plug in -9 here with -9 squared. Minus 4 times a. And what's a? That's 3. Times c. What's c? -12. Okay, so that's the square root. And then we need to divide by 2 times a. And a is 3. So now we have plugged in our particular example here into our general formula. Okay, so what do we get then? So let's continue here. This minus 9 is 9. Plus minus, this is 81. So we have square root 81. And here we have minus, so that becomes plus. And here is 12 times 12. So this is 144. And this is 6. So 9 plus minus, this is 225. Divided by 6. So what is the square root of 225? Yeah, you can calculate it, or you can remember it from seeing it before, and it actually is 15. So if you square 15, you get 225. So this. And now we have two possibilities, plus or minus. So this is plus 15 divided by 6, or 9 minus 15 divided by 6. So 24 divided by 6, that's 4. And minus 6 divided by 6, that's -1. So we see that we get the same solutions as before, -1 and 4. So this is how you can use this explicit formula to find the solutions directly. If you would find that what you have here under the square sign is equal to a negative number, then it means that there are no solutions, because you can't take the square root of that. And if you happen to find that this is exactly 0 under the square root, that means that we will only one solution instead of 2. Now let us just prove this formula here. So let us take a general quadratic equation. Now the technique is to do what we did before, to write this in the form of ax plus b squared plus c. So you have to write the left hand side as this, because if we can do that, we can easily solve it. Okay. Now we go a little bit quicker, so if it goes too fast, you have to pause the video and do like that. So let us first factorize out a, and then we will get this. If I take out a, then what remains is b divided by a. And here's c divided by a. Okay, this a, now we can assume that this a is not 0, because otherwise we wouldn't have a quadratic equation. This will just disappear. So let us now divide both sides with a. It means that it just disappears. And now we can do our normal trick. We write this as a square or something. So what should we put here? X squared, that's that one. Now we have to have the double product here. So what we should get this. That means what we should write here should be half of that. So it means it should be half. It should be this. Because now this times 2 will become this one. But now we also get the square of this one. So we need to take away the square of that one. And what's the square of that one? That's this. And why is that? Because the square of this is b squared, 2 squared, a squared. Because if you use one of the rules that we can, all of this should be squared. And this is just this. So this, if you have the square of that, we get this. But you don't want that, so we have to take away that. That is, we have to take away b squared, 4a squared. But we still need this one. Okay, let us now move this. This is a constant. The only place where we have an x is here. The rest is just constants. And we can assume we already know what those are. Because every time we come across the equation, we know what a, b, c are. So just move this constant to the other side. Then we'll have b squared, 4a squared minus c. They just change signs. And now we do the usual thing. Here we have a number we should square, should be equal to that. That means that this number inside the parentheses must be plus or minus the square root of this. Okay, let me just now remove this. Okay, so we continue with this one. What should I do now? Let's move this over to the other side, because we want x alone on the left hand side. This becomes this. And now, under the square root, now we want to bake these two together. So let's make the same denominator. So we keep the first one intact. But the second one, we have to multiply up and down by 4a. So if you multiply up and 4a, so this becomes 4ac. And down we have 4a2, because now they become the same in the denominator. Okay, and here now we have the same denominators. We can put them, take them together like this. And now we take the square root up and down, because we have a rule for that you are allowed to take the square root up and down if you have a square root of a quotient. Okay, so here we have up b squared minus 4ac. And here in the denominator, what is the square root of 4a squared? Yeah, that's just 2a. if you square 2a, you will get 4a squared. You can also get plus and minus, but we already have plus and minus here, so we already have taken care of that. And now we see that we have the same denominator, so let's put them on the same as one fraction. And we have arrived at the formula we wanted to arrive at. So this is the formula, explicit formula. So we see that the explicit formula we actually use the other technique we have seen here, that write a quadratic function as in this form ABC form. So we see that we're always using that technique even if we use this formula explicitly. This is only a shortcut. Okay, let us just finish this chapter by seeing how to solve a quadratic equation graphically, because now we have solved it algebraically. So if you have, for example, x squared minus 1, and we want to solve this equation. Yeah, we have seen that algebraically we can solve it in the following way. We can just move over to 3x to the left hand side. Then we will have this one. And this now we can solve in the normal way. We can either write it as a parenthesis squared and so on, or we can use the direct formula we just seen. However, this formula here we could also use to solve graphically, because this what we have talked about so far is algebraically. It's preferable most cases to do it algebraically, because you get exact solutions. When you do it graphically, you only can estimate, because you can never draw a perfect figure. But it's good to also be able to do it graphically. So how can you solve this graphically? Here you see that we have two functions. On the left hand side we have this function. On the right hand side we have this function. So on the left hand side we have a quadratic equation. On the right hand side we have this linear equation. And they should be equal. What does it mean that two functions are equal? Okay, let's draw this in GeoGebra. Okay, so let's draw our two functions. So we have x squared minus 1. And then we have 3x. Okay, so here we have our two functions. Let's zoom out a little bit. So we see here that the green one now is x squared minus 1, and the red one is the straight line 3x. Now we want to find out when these two functions are equal. What does it mean they are equal? That means they have the same y value. That means that they cross or intersect. And we see that they intersect there and there. Okay, so let's say we zoom in here now. So you see here they intersect here, and what x value is that? So if you go down here, is 3 point something. Okay, we could put a dot here in the section point. There is also a function to find intersect. But let's see just roughly. We see it intersect at 3.3. So a graphic solution to this is 3.3. So we see that these are equal at x equal to 3.3. Because at 3.3 they have the same y value, or roughly 3.3. But we also have one more solution. So if you go down here, see we have one solution here also. And that's roughly at minus 0.3. So we have one solution at minus 0.3 and one solution at 3.3. So we can find the solutions in this way also, doing it graphically. But we could also do it like this. Instead of writing as equality of two equations, two functions, we could just write everything on the left hand side. So let's put everything on the left hand side. We see these two equations are the same or equivalent. So let us install instead draw this, the graph of this one. If you draw the graph of this one, what are we want to do then? We want to find out when it's 0. So let us draw this now. Okay, so here we have x squared minus 1 minus 3x. And let's remove the other ones. So you see here now, if we take let's zoom out. So this purple now is this function. Now we want to find out when is this function equal to 0, because that is what we are looking for. And that means that we should find the point here and the point here where it crosses the x-axis. That's the solutions to the equation. Then we can just zoom in here. We see that 3.3, as we've already seen, and minus 0.3. So we could either do it in the first way when we had two functions, see where they intersect, or we can just take one function by moving everything to the left hand side, and we have this function, and just see where it's equal to 0. So we can do either way. So both of these are examples of solving it graphically. But you see here that we are limited to approximate solutions. So if you want exact solutions, we should do it algebraically.